Hi guys, welcome back to BioBulletin. Today we're going to discuss the reprogramming of skin cells to produce insulin, diving deep into new research in the science of diabetes.
Yeah, so Viven, as you mentioned, diabetes is clearly a huge issue, and this whole idea of reprogramming skin cells for production of insulin is very promising. But for those of our listeners who don't know, diabetes is a chronic, long-lasting health condition that affects how your body turns food into energy. So most of the food you eat is broken down into sugar, also called glucose, and then released into your bloodstream. And when your blood sugar goes up, it signals to your pancreas to release insulin, which acts as a key of sorts to let blood sugar into your body cells for use as energy. Insulin is produced by cells called beta cells, and there are two key types of diabetes. So there's type 1 and type 2. Type 1 is where the body attacks the cells in your pancreas, meaning they will not make any insulin, and it's thought to be a type of autoimmune rejection, but the actual exact cause is still unknown. It is it is well, what we know about it is that the beta cells here are destroyed by the immune system. Um, type 2 causes blood sugar levels to be increased and for insulin not to function correctly, and thus incorrect amounts of faulty insulin, so to speak, are produced by the pancreas. So the beta cells malfunction while the other cells develop insulin resistance and so require higher and higher levels of to effectively lower the sugar levels. And this leads to homeostatic issues as the body's blood sugar levels cannot be kept at a steady level. So some quick stats: be 8% of people have type 1, whereas 90% of people have type 2 diabetes, and the remaining 2% have other rarer types which aren't as common. It's estimated that a total of 415 million people are living with diabetes in the world, and that's estimated to be 1 in 11 people of the world's adult population. 46% of people with diabetes are undiagnosed, and at least 10,350 people in the UK have end-stage kidney failure because of their diabetes. More than 1,700 people have their sight seriously affected by their diabetes every year, and there's a new diabetic diagnosed every 2 minutes. There are 500 deaths a week as a result of diabetes and 169 amputations, as well as 2,000 cases of heart failure.
So I'm going to be giving you a brief explanation about the two types of treatments for two types of diabetes. So if you have type 1 diabetes, you'll have to take insulin because your body no longer can support you making this hormone. So you'll need to take insulin several times during the day, including with meals. And you can also use an insulin pump, which gives you small, steady doses throughout the day. So people with type 2 diabetes can manage their diabetes by making healthier food choices and being more physically active. So many people with type 2 diabetes may also need diabetes medicines, and these include pills or medicines that you can inject underneath your skin, such as insulin. You may need more than one type of diabetes medicine to control your blood glucose. Even if you do not take insulin, you may need it at special times, such as during pregnancy or if you're in the hospital.
Ashish, I heard that type 1 diabetics always need insulin injections. Is that correct?
Yes, they do, and that's why you can use a pump to give small and steady doses throughout the day rather than going to and from the hospital regularly. So most type 1 people that suffer from type 1 diabetes will have a pump, or they monitor it throughout the day to make sure that their blood glucose level doesn't go dangerous either way.
Ashish, with that current process, there surely must be a couple problems. Like, I know that insulin injections take time to reach the cells, so there is that lag time after injection during which the blood sugar can still rise to those damaging levels. And also, because of those lowered insulin production, glucose can build up in your bloodstream. It's called hyperglycemia, and it could reach dangerously high levels if it's not treated properly, resulting in nerve damage, the cataract becoming clouded, and even amputation. Maybe there's a new method that we need to talk about. And I think that's where the reprogramming skin cells comes in?
Yeah, Viven, that's correct. So they are what they're trying to do is reprogram human skin cells to produce the hormone that is insulin, and that has the potential to really help diabetics control their diabetes. So the new skin cells are in the very early stages of development and have not actually been placed in the human body as of yet. Um, the reason they're especially promising is that they could help individuals with type 1 diabetes as well as type 2 diabetes, with type 1 generally being considered the worse and harder to treat of the two. But that does raise the question: how are these skin cells reprogrammed, and how are they collected? So what they did was they um, obviously have so they extracted the skin cells from newborns, but that can have ethical implications. Was avoid those by taking them from the foreskin of male babies, which would otherwise have been discarded after a circumcision. And then they reprogrammed these skin cells to pancreatic cells using a method of combining the skin cells with these specific molecules, which instruct the cell to revert to an earlier stage of cellular development, and then they differentiate and multiply. Um, it's it's kind of fair to say they turn back the clock of the cell to the point where they resemble the cell in the endoderm, which is a very early embryonic layer. And it's this layer which then develops into the majority of the internal organs, including the pancreas. So they've had some issues in that they don't seem as effective at producing insulin as the naturally developed human pancreatic beta cells, but they have had some highly promising results when tested in mice and have real potential to impact the lives of patients with diabetes and really change their quality of life.
Yes, Kanishka, in this study, the scientists first used pharmaceutical and genetic molecules to reprogram skin cells into what's called endoderm progenital cells. So that's early development cells that have already been designed to mature into one of a number of different types of organs. With this method, the cells don't have to be taken all the way back to a pluripotent stem cell state, meaning the scientists can turn them into pancreatic cells much faster. The researchers used a similar procedure previously to create heart, brain, and liver cells. After another 4 molecules were added, the endoderm cells divided rapidly, allowing more than a trillion-fold expansion. So critically, the cells did not display any evidence of tumor formation, and they maintained their identity as early organs. The scientists then progressed these endoderm cells 2 more steps, first into pancreatic precursor cells, and then into fully functioning pancreatic beta cells.
Mm.
So I think it's going in the right direction.
Yeah,
I mean, I've been researching possible problems with this project, and I read that there's going to be a lot going on around the gut area, and so there's loads of different responses that are triggered by different hormones, and there's receptors detecting all different things that are going on. So we have to be careful about what type of cells we're trying to reprogram and what effects that will have on the environment that they're in, because we don't want to have the case where it makes a negative effect on the environment, because that could deal with catastrophic effects. So we have to make sure that we have all of our research 100% correct. And I think, yeah, it has to be perfect before we even begin human trials or even think about beginning human trials.
Yeah, definitely. I'd fully agree with that. I think, currently you're talking about trials. They've tested it on mice a little, and I've heard that they've got somewhat promising results. But I don't know if anyone has more detail on the experimentation with mice and stuff like that. But I think generally, Ashish, what you said, is true. We definitely need to make sure everything we're doing is ethical and good, and be careful with before we put it into human bodies.
Just to track back a little bit, before the mice, scientists tested these cells in lab dishes, but they didn't place them into the human body to see if they can produce insulin in that setting. And they also noted that the cells are not completely identical to the human pancreatic cells that normally produce the insulin in the body. But there has been a much closer, more successful experiment with those mice that you mentioned, Kanishka. So the scientists transplanted PPLC cells into mice that was subjected to hyperglycemia, which I mentioned previously. The results came back that barely a week after the transplantation, the glucose levels in the mice started to decrease, approaching the normal levels. So when the transplanted cells were removed, an immediate glucose spike was seen. When the mice were tested 2 months after, scientists discovered that the PLCs had given rise to a new insulin-producing beta cells. So the study represents basically the first successful creation of human insulin-producing pancreatic cells. I think the final step was the most unique and the most difficult.
Sorry, yeah, I was just going to say, when I was doing my research, I also found that the lead scientist on the whole experiment said that if and when the cells make their way into humans and are actually used in clinical use, they're most likely going to need to be contained within a capsule of sorts, and that kind of has two key effects. So the first is protecting the cells from the immune system and launching an immune response and immune rejection on the cells, because they would obviously be considered a foreign body, and to protect the body in case the cells were to have tumor forming properties. So I know you mentioned that they weren't found to have any tumor forming properties, but you never know how that could change with time or anything like that. But just a kind of broader question, what do you guys think about testing on animals? Obviously in this case they've been testing on mice, but do you have any religious perspectives on that? Or
personal opinion, I think obviously it's wrong. It's going against basic principles of Hinduism. Again, ahimsa. I'm keep going back to that one, but it's important because it's a basic principle that we have. And just non-violence to all beings, because they do have souls and consciousness, so they can also feel pain. But then again, we also have to balance that out to the fact that they're specifically bred for that purpose. So whether that raises the question that they're on a lower level of consciousness because they're not bred for any other purpose apart from helping us benefit human life. So we could argue that testing on animals, yes, it's wrong, but because lab mice are bred for that purpose and we're only using them for that particular purpose, it's all right. So
I think that utilitarianist doctrine that actions are right if they're useful or for the benefit of the majority, I think it links to what you just said, Ashish. So it's saying that this animal could be tested to save a human, and that's worth the killing.
I think from a Christian perspective, which is the best perspective I can give, I'd say a lot of people turn to Genesis and they talk about Genesis 1:28 and stuff like that when the Bible refers to God producing animals for our purpose, and that thus we should use them in whatever we can, whatever way we can, to benefit us. But I think it's also kind of important to make sure we understand that God also made these other living things, and they're all we are all living animals and creatures of God, and thus to kind of just disrespect their life by using it in any way we see fit, I think is partially immoral, but that's a whole different podcast again. I think to conclude, it's been a very interesting discussion. Diabetes is obviously a huge issue, and this idea of reprogramming skin cells to produce insulin is seemingly very promising. I think there are a few issues that we perhaps need to kind of iron out prior to actual testing in humans or human challenge trials or anything like that. I think generally the idea in itself is something that has wider application, but the ethics and religious perspectives need to be taken into account when doing the testing, although the science itself is very promising.
Yeah, I think that's a great summary for the entire podcast. Thanks for listening, everyone. Please make sure you like and subscribe, leave any comments, or tell us about new topics or exciting discoveries on our Google Forms. Make sure you don't forget to follow our Instagram, and we've also recently set up a Twitter handle, so go follow that as well. Thank you, guys.
Thanks.